doing 11.1. We're going to be talking about polygons, and our essential question today is how can we identify and classify polygons? That's where we're going to start off at. The first thing we're going to look at is this picture here of a castle in Italy that was built 750 years ago. It says the fortress has one central building with 8 surrounding towers. The question is, which polygon do you see repeated in the structure? How many sides, angles, and vertices does this polygon have? So to answer this question, we have to talk about a few things. We need to talk about what is a polygon. And so we'll drag this out here. And it says here that a polygon is a closed plane figure formed by 3 or more line segments that meet at points called vertices, and it's named by the number of sides and angles that it has. So let's break this down. A closed plane figure. So what that means is that a polygon is closed. So if we were to draw a picture here, and this picture looked like this, you can see that right here we don't have a closed figure because not all of the sides meet at vertices. So in order to draw a closed figure, we need to make sure that we connect all of those line segments. Additionally, for a shape to be a polygon, all of our sides have to be straight. They can be crazy and they can start out in so many different ways, but as long as they're all straight and in the end they close off the shape, then we have a closed plane figure. Another way to think about this is that if we were to fill all of these shapes that we have drawn here with water, would the water leak out of any of them? We can see here in our first one that yes, it would come out because we have a giant opening. Our second one that we drew, all of these come together. And if we look really closely at our third one, we may have noticed that right down here in this corner, that it is actually open. So let's go ahead and make sure that we close that off. That didn't work out very well, but you get the idea. We need a closed figure in order for it to be a polygon. Now, a plane just simply means that it is all operating in one or in our two-dimensional area. So we're not dealing with three-dimensional shapes here. We're not dealing with shapes that go from one plane to another. That's a kind of a harder concept to understand. But if you think of like the top of a desk, that could be a plane. If you think of a wall in a room, that could be a plane. Even if you think of like the roof of a house, which is at an angle, that's not like flat or 90 degrees, that is still all within one plane. So that's what they're talking about when they talk about a plane figure. So let's go ahead and look at some polygons and see if we can get them classified. Here we have our chart. They have a picture of our polygon and its name here in the top. Our first one is a triangle, and a triangle has 3 sides. Now, we also need to identify its angles. The angles are going to be on the inside of our shape. So here we see that a triangle has, in fact, got 3 angles. Now, vertices are where our sides meet to form a point. It's kind of like the outside part of our angle. So our triangle, in addition to having 3 sides, 3 angles, it also has 3 vertices. Basically, any place that there's an angle, there's going to be a vertice to go along with it. Next up is the quadrilateral. Quad stands for 4, and so lateral means sides. So a quadrilateral has 4 sides, and we can count them here: 1, 2, 3, and 4. In addition to having 4 sides, our quadrilateral has got 4 angles to go along with it. I'm going to erase these numbers just to kind of clean it up. But it's going to have 4 angles to go along with it. Again, these are the inside parts of our corner. And just like we said with a triangle, If there's an angle, then on the outside of that angle is where two sides meet, and that's going to be our vertice. And so here we have 4 vertices. Moving on, we have our pentagon. And here pent means 5, P-E-N-T, and we have 5 sides in our pentagon. We can see them here, 1, 2, 3, 4, and side number 5. We also have 5 angles, even though they look a little bit different. This is normal, 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 normal. And our odd looking angle is going to be this one right here. And this is what we call an obtuse angle. This angle is just greater than, well, it's even more than obtuse, but it's greater than 180 degrees. But it's still an angle. And in the middle of it, we still, in fact, have right there a vertice. So we have 5 angles, and again, you guessed it, we have 5 vertices. Hopefully you're noticing that the number of sides is equal to the number of angles is equal to the number of vertices. And we see that with our triangle, quadrilateral, pentagon. We're also going to see it here with our hexagon. Hex, H-E-X, means 6. And if we look here, we have 1, 2, 3, 4, 5, and that is a terrible 5, and 6 sides. We also have 6 angles, and again, we are going to have 6 vertices to go along with it. All polygons are going to have the same number of sides as angles as vertices. So really the only thing that we need to focus on in our lesson today is knowing the number of sides related to the name of our polygon. These should be pretty easy, right? Triangle, quadrilateral are definitely easy. Pentagon, hopefully you recognize that that's 5. Hexagon is 6. Now we're going to move into some new ones for us probably, here with heptagon and nonagon. So hept, H-E-E-P-T, stands for the number 7. And if we were to look at this one, we would see that we have 1, 2, 3, 4, 5, 6, and 7 sides. And just like with our other page, we're going to see that we have, in fact, got 1, 2, 3, 4, 5, 6, and 7 angles. And if we have an angle, then we obviously are going to have a vertice. Octagon, octa, octopus, octagonal, all of those things mean the number 8. And you should be very familiar with this. We see stop signs all the time, and they have 8 sides, they have 8 angles, and 8 vertices. Another new one, nonagon. I feel like this one's kind of easy because N in nonagon is, the same number or letter that the number 9 starts with. And a nonagon has, in fact, got 9 sides, 9 angles, and 9 vertices. Again, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then our last one is decagon. We see deca all the time. Decade. We just learned about the metric system where we had decagrams, decaliters, and so on and so forth. And here we're going to have 10 sides, 10 angles, and 10 vertices. So going back to our original question from the previous page, what is the polygon that we see repeated here in our picture? And hopefully we can see that here in the middle we have one, and then each turret is also going to be one, and then the central part of the building is another one. And if we were to look at it really closely, we would see that we have 1, 2, 3, 4, 5, 6, 7, 8 sides. And we just reviewed that an 8-sided figure is called an octagon. So that's what we see there. All right, now, in addition to being able to name polygons based on the number of sides, angles, and vertices that they have, we can also differentiate between regular and non-regular polygons. Now, a regular polygon is a polygon where we have all of our sides, all of our angles are all going to be congruent. So what congruent means is it's a fancy way of saying the same. So congruent just means the same. And not just kind of the same, but exactly the same. So here, if we look at this polygon, we see, first of all, that we have 1, 2, 3, 4, and 5 sides. So a 5-sided figure is called a pentagon. And then if we take a look at this, we see that all of the side lengths are exactly the same. They're all 4 centimeters. So that's good. Now, the second part of this is that we're going to look at our interior angle measurements, and we see that they are all 108 degrees. So if we have congruent sides and congruent angles, then that means that we have a regular pentagon. So this is, in fact, a regular pentagon. We can have regular triangles, we can have regular quadrilaterals, regular octagons and decagons. All of those can also be regular. Now, if it's not regular, then it's just a non-regular polygon. And a non-regular polygon is just any polygon that doesn't meet these criteria. So if we draw another pentagon and we draw it looking like this with super tall bits and doesn't look the same, again, here we have 5 sides, 1, 2, 3, 4, and 5, but none of them are the same, and so this is a non-regular pentagon, whereas over here on the left side of the screen, we can see that they're all the same. We just went over that, making it a regular pentagon. Now, when we are talking about regular polygons, a lot of the time what you'll see is that they won't include the actual length of the sides or the actual angle measurements. And instead what you'll see is that along the outside of the polygon on each of the sides, if they're the same, they'll just put a little tick mark to let you know that these are all the same. We can also see them do the same thing with our angles. So what they would do is they would just draw one little line for each of them to show you that they are all exactly the same. Now we can see this happen with triangles. Sorry, that's not the one that I meant to draw. What I meant to draw was this one, right? So here, we take a look at this. Right here, we have these two sides are going to be the same. These two angles are going to be the same, but the others are not. And the way that we can tell that they're not is because, again, here we have one little tick mark for each of these, whereas on this longer side down here, we don't have a tick mark representing that it's not the same. Additionally, with our angles on the inside, we have one little arch drawn for each of these angles. Down here in the other corner, we don't have one of those. So let's draw one more, except for we're going to open up a new page, and let's draw this. So here on this one, first of all, hopefully we are beginning to recognize that we clearly don't have 4 congruent sides. This is not going to be regular. But what we would do here to show that is here they would put one tick mark on each of those because those two sides are the same. And then the other two sides are also going to be the same. And so what they would do here is we would add 2 tick marks. So here these are the same. Our top and our bottom are the same but different from our 2 longer sides. The thing to remember is that because for it to be regular, remember we said that all sides had to be congruent as well as all angles. So this one meets a lot of that criteria, except for the fact that, again, we don't have all four sides. We only have two different sets of congruent sides. So this, in fact, is not regular. All right, moving forward. Here's a nice little Venn diagram that kind of puts this all together for us. If we take a look on the left-hand side, and it's kind of tricky to see, but hopefully what we're seeing is that on the left-hand side, we have congruent angles, and one little sign that we can do for that is just a little angle. So on the left, we have all congruent angles, but just like we talked about on the last picture, here, for example, we have two different sets of congruent sides. We don't have all congruent sides over there. On the right-hand side, on the other hand, we have congruent sides, right? You'll notice that on all of these that we have one little tick mark for each of the sides, representing that they're the same, so that we have congruent sides. But in the middle, we don't have congruent angles. This orange one down here, for example, we see that 4 of the angles are the same because they just have one little arc in them, but the top angle and the bottom angle actually have 2 little arcs representing that they are different. So right-hand side, we have congruent sides. Left-hand side, we have congruent angles. And then here in the middle, this is where we have our regular polygons because they have all congruent angles and all congruent sides. All right, so let's put all of this to work here, and we are going to name some polygons. So this polygon is a triangle because it has 3 sides. And then what we need to look at is, are all of the sides and angles congruent? So here we see one little tick mark on all 3 sides, which means that yes, all sides are congruent. And then in the corners, we say that we have just one little arch. So all angles are also congruent. So the answer is yes. So is this a regular polygon? Then yes, this is in fact a regular polygon or a regular triangle. All right, let's try a couple on your own. So take a look at these two and figure it out. Is this a regular quadrilateral and a regular triangle? All right, this one on the left is in fact regular. Here we see that all 4 sides are the same, and then we also see that all 4 corners are also the same. And a quick note is that whenever we see a squared off corner like this with a little square drawn in the middle, that just means that this is a 90-degree angle or a right angle. All right, looking at the one on the right, here we have 2 congruent sides, but this third side is not the same. So this one, we don't even need to go any further. This one is not a regular polygon. Trying again with 2 more. All right, let's look at the one on the left. What do you think? Is this one a regular polygon or not a regular polygon? The answer is it is in fact regular. And then the second part of this is that they want us to name each polygon. So here we have 1, 2, 3, 4, 5, 6, 7 sides. And hopefully you remember from earlier in the lesson that that means that this is a heptagon. All right, the one on the right here, regular or not regular. And of course, this one we see that these two are different than all of the other sides. So this one is not a regular polygon. Now let's name it. Hopefully we can see that there are 1, 2, 3, 4, 5, 6 sides. And so a 6-sided figure is a hexagon. All right, final question that I would like for you to think about is we want to look at all of the angles for all regular polygons. And it says, as the sides increase, do the measure of the angles increase or decrease? What do you see? So let's draw a couple. So we'll draw a triangle. We will draw a quadrilateral, a regular pentagon, regular hexagon, and then let's get all the way up here. Whoops, didn't mean to do that. Draw that a little bit bigger to a decagon. So as we look at these and we look at the size of each of our angles, right? Hopefully we're starting to notice that these three angles and the triangle are a little bit smaller than our angles in our quadrilateral. And those are going to be a little bit smaller than the angles in our pentagon. And one way that we can maybe try to show this is, let's see if we can drag it over, right? And so again, you can see here that the the opening of the angle for our quadrilateral is larger than that angle for our triangle. And the same is going to be true as if we were to slide this quadrilateral over the top of our pentagon. If we put our pentagon on top of our hexagon, hopefully we're starting to see that the opening of our angles has to be greater for our different polygons. The number of sides means that each of those is going to open up wider, and it'll work here too. If we drag anything over here on top of our decagon, right, we're going to see that our decagon gets a little bigger, and it doesn't really matter the size of our polygon that we're putting on top, because in all reality, all angles in a triangle, or I'm sorry, not a triangle, all angles in our quadrilateral are always going to be 90-degree angles. And it doesn't matter if our quadrilateral is this size or if our quadrilateral is significantly bigger, we're going to have that 90-degree angle. And that is just for regular polygons, because obviously we could draw any kind of kooky like quadrilateral that we wanted, right? And these aren't all going to be 90 degrees. But if it's a regular polygon, all of the angle measurements are always going to be the same. So that's just something to keep in mind and to think about as you work through this. We're going to try to clean this up just a little bit. Maybe not. Never mind. Yeah, so that is our lesson for today. Remember that our question was, how do we identify and classify polygons? And hopefully what you learned is that we name polygons based on the number of sides and angles that they have. And then we can classify polygons as regular polygons if all of the sides and all of the angles are congruent. Remember, congruent was just our fancy word for the name same.